dodecahedron table. So what does this mean? It essentially is a table with 12 numbers. Right? So let's put our 12 numbers in. Help us visualize. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. We are then told that this table actually has a 13th side, a double green bonus side. So we're going to call this the 13th option that we can have for this table. A statistician observed this game happening thousands of times, and he noticed a pattern that the numbers 1 to 11 all had the same probability of occurring. And the numbers 12 and the double green bonus, or 13 in our case, have half the chance as the rest of the other numbers, 1 to 12. So the first thing I would do is try to get a probability mass function table up, and I would do this as follows. I would put my x and my probability that x is equal to x. So I put my numbers there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the double green bonus, which I'm calling 13. Right, so how do I get these numbers? I say, well, if the probability is the same from 1 to 11, I'm just going to call it k for each of them. Right, so that's from 1 to 11. And then 12 and 13 have half the chance as the rest, so half k. Now, I need to find this value of k. What do we know about probability mass functions? That if we sum up all the events from this sample space, then what should we get? We should get 1. So that's an important formula to remember. So let's go ahead and add up all those values. So the sum of the probability values in our sample for this dodecahedron table is going to be k plus k all the way up to plus k. That is how many k's? That's 11 times, plus half k plus half k for 12 and 13. So I'm going to get 11k, and then half k gives me 1k. So I get 12k altogether, and that must equal 1. So this implies that k must be 1 over 12. Okay, so now we can actually go ahead and write this probability table out nicely. So let's go and do that. So x, probability that x equals x. Right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the bonus. Right, and then we now know what each of the probability values are. So that'll be 1/12, 1/12 for all the numbers up to 11. And then from 12 and 13, we said it's half k. So half k, which is half times the 12th, which is 1 over 24. So how does this help us now? We need to know a certain expected value formula for when it comes to betting. And what is this formula? So this is a super important one here. So the expected value of winning a game when you bet is the probability of winning that game times the amounts that you win minus the probability that you lose the game. So a loss times the bet amount, how much you bet on that certain game. And this expected value formula is sort of an average of what you would expect over time as you keep playing more and more games over a period of time. So, how does that help us here? Well, we know the probability of winning and losing if we had to, but how do we know the amount won and lost, and the amount we bet? So in the question, it tells us we bet 1 rand on the number 1. Okay? We want to know what is the expected gain or loss per play. So expected in this case is if you kept playing this game over lots of times, how much do you expect to win or lose as you keep playing these games over and over and over? So we need to say, what is the probability of winning? So if you bet on the number 1, what chance do we have for the number 1? Well, there's a 1/12th chance of winning. How much do we win? So this information was given as well. We said that if you win, you get 11 rand. And this is applicable for the numbers 1 to 12. It also says if you win for the 22, for the bonus green case, you get 23 rand because it pays odds 23 to 1. So that's for the number 13 for the bonus. So we're actually interested just in this case here because it's between the numbers 1 and 12. We're picking the number 1. So you could win 11 rand, but that's not how much you actually win because you've already bet that 1 rand. So if you do win 11 rand back, you've actually only gained 10 rand back. Okay? And then what is the probability of losing? Well, if you don't win, if you don't get the 1 over 12, there's 11 out of 12 chances you'll get a different number. Right? And what is the amount that you bet? You bet 1 rand. So simplifying this, we get 10 over 12 minus 11 over 12, which gives us negative 1 over 12, which is roughly negative 0.08. So this means, therefore, on average, as you keep playing more and more of these games, you lose 8 cents. So I hope this helps. To recap what we said, the expected value for when you bet over a long period of time, what is the average gain or loss you're going to get, is the probability of winning times the amount that you can actually win back after you bet, and then minus the probability of actually losing that round in that game, and the money that you actually bet on that round.